J.R.R. Tolkien had this idea for his elves. He called it a sea longing. After thousands of years, they just felt this deep, undeniable pull to leave the world they knew and sail to a distant shore. And I think we have that too. We feel a sea longing. But for us, the ocean is space. It really feels like we have two options. Either Earth is our cradle and our grave, or we take a chance and spread out into that incredible night sky. And that choice, staying or going, is what drives the biggest, most ambitious engineering dreams our species has ever had. I mean, this line from Interstellar just nails that feeling, doesn't it? It's the voice of our ambition. But to actually make that dream a reality, whether it's just exploring our own solar system or, actually going to other stars, we are going to need a truly unbelievable amount of energy. And when you start thinking about that much energy, it forces you to think on a completely different scale. You start imagining these incredible technologies, the kind that could power a civilization that spans the stars. And the most famous of these, maybe the most misunderstood, is the ultimate power station. Yep, we're talking about the Dyson Sphere, this gargantuan artificial shell built to completely surround a star, capturing every single watt of its energy. It's such a seductive idea, right? It would be a leap for humanity as big as the discovery of fire. And just look at the prize. A full-on Dyson Sphere would give us access to 400 septillion watts of power. To put that in perspective, that is 1 trillion times more energy than our entire civilization uses today. With that kind of juice, things like terraforming planets or building starships, that all moves from science fiction right into the realm of engineering. So how would you even begin to build something like this? Well, the most plausible plan isn't a solid shell. That's basically impossible. It's what's called a Dyson swarm, a massive cloud of individual solar collectors. And the plan sounds kind of straightforward, believe it or not. You'd start by disassembling a planet like Mercury for parts. You build an automated factory there and then use electromagnetic railguns to just start launching satellites. But here's the magic trick: exponential growth. Every new satellite you launch gives you the power to build and launch the next one even faster. So 2 become 4, 4 become 8. And in just a few decades, you could actually surround the entire sun. Okay, but as with all these grand, beautiful ideas, this is where physics comes in and kind of ruins the party. The Dyson Sphere, even as a swarm, slams into some really fundamental problems that are, well, they're really hard to get around. So it doesn't matter if you're dreaming of a solid sphere or a cloud of satellites. You hit these total showstoppers. A solid sphere isn't just hard to build, it's gravitationally unstable. See, the star and the sphere don't really pull on each other in a stable way. So any tiny nudge from a passing comet or whatever, and the whole thing could just drift and crash right into the sun. A swarm avoids that, sure, but then you've got a massive material shortage and the frankly mind-boggling task of coordinating quadrillions of separate orbits for, ever. And this quote just illustrates the material problem so perfectly. It's like trying to build a shell around a basketball, using only the material from a single human eyeball. It doesn't matter how you slice it, you just don't have enough stuff. Even if we took apart Mercury, Venus, and Mars, it's still not enough. So, here's the reality check. The Dyson Sphere is an awesome thought experiment, but it's a brute force solution. It needs materials that don't exist, it's dangerously unstable, and it requires more matter than we actually have access to. It's less of a power station and more of a cage we'd be building around our own star. And this is where we get to a really fascinating pivot. If building the ultimate cage is just too hard, what if we've been asking the wrong question? What if instead we tried to build a catapult? A way to actually answer that sea longing and finally reach the stars. Now, we've had ideas for interstellar travel, like Breakthrough Starshot, which wants to use giant lasers to push tiny sails. And they're super inspiring, but they also have these huge engineering challenges and cost a fortune. So you have to wonder, could there be a cheaper way, a more clever way to use the physics we already know? And the answer comes from this really simple, elegant insight. Think about a solar sail. Its biggest problem is that the push from sunlight gets weaker and weaker the farther away it gets. But what if you didn't have to move right away? What if you could just sit in one spot, soaking up that free solar energy for years and just store it? You need a kind of battery. And it turns out a simple spinning flywheel is one of the oldest kinds of mechanical batteries there is. This simple idea A solar-powered flywheel leads to one of the most brilliant and clever designs I have ever come across for an interstellar launch system. It's called TARS. The physics behind it is actually based on this little desk toy, a radiometer. It's super simple. In a vacuum, sunlight actually pushes on things. And here's the trick. It pushes twice as hard on a reflective surface as it does on a dark, absorptive one. That difference in pressure creates a tiny twist, a torque, that can make something spin. So picture this. You have a long, thin ribbon in space. One side is shiny, the other side is dark. The constant pressure from sunlight makes it spin, faster and faster and faster. Now, to keep it from just getting pushed away from the sun, you put it in this special stable orbit, a quasi-Zeit orbit, where the push from the sun is perfectly balanced by gravity. So it just sits there for a few years, spinning up, storing a huge amount of kinetic energy like a battery. Then, right at the last second, just before it tears itself apart from the speed, it releases a tiny microchip from its tip, flinging it out into the cosmos like a stone from a sling. And in this awesome case of life imitating art, the concept got its name, TARS, which stands for Torqued Accelerator Using Radiation from the Sun. It was directly inspired by the physics of that spinning endurance spacecraft from the movie Interstellar. It's just so cool when science fiction inspires real science. And look, this isn't just a fantasy. Using materials we can literally make right now, like carbon nanotube sheets, you could build a TARS system that weighs only 1.6 kilograms. After charging up for just 3 years, it could launch a probe at over 40 kilometers a second. That's fast enough to escape the solar system entirely. No giant lasers, no taking planets apart, just really, really clever physics. You see, TIRS isn't about getting to Alpha Centauri tomorrow. It's about changing how we think. It suggests a totally new philosophy for these megastructures, not about brute force and raw power, but about elegance and ingenuity. It's a plausible first move in a much bigger game. And that first move can be upgraded. Oh boy, can it be upgraded. With stronger materials like graphene, you could spin it faster, you could use clever orbital tricks and gravity assists from planets to get a speed boost. But the most exciting upgrade? Electric reinforcement. By giving the ribbon an electric charge, you could create a force that fights against the centrifugal force, letting it spin way, way faster. How much faster? We are talking about a potential speed of 1,000 kilometers per second. That is a massive improvement. No, it's not the speed of light, but at 0.3% light speed, it represents a monumental leap. It means we could start sending probes to other stars and get data back within a single human lifetime. And that's the beautiful thing here. Sometimes the laws of physics feel like they're holding us back, but then they turn around and allow for something as elegant as this. It really feels like we're just beginning to understand the rules of this grand cosmic game, and TARS is this perfect reminder that the cleverest moves aren't always the biggest or the most powerful. Which brings us right back to the beginning. Where do we put our energy? Do we spend our future trying to build an immense cage to trap the power of our home star? Or do we focus our ingenuity on building the catapults that will finally let us answer that sea longing and set sail for those distant shores? I guess that choice is up to us.